Lake Shore Picnic Point, yeah, they had a bunch of burned out stuff, that's right.
It was a couple of years ago. It was a
Yeah. Well, some of it is, some of it's burned too, it's kind of a small section. Some
We'll get ready whenever you are.
Sure.
Start with the week-long. So welcome to Weather Watch for March 15th. I'll be doing an abbreviated discussion because Professor Lopez-Lang will tell us about the polar vortex. And yeah, so I will go very quickly. Yeah, correct. So I'll start out with my week-long IR loop as I like to do. And I'll let this play once and then highlight some things. First of all, you can notice there's almost persistent low pressure over the northeast that you'll see. So that system does not move, it just kind of dies out, loses its moisture. We'll notice at the start of this loop, here's your next system moving into the western United States. This is what brought us our rain, what brought severe weather, what brought 36 inches of snow along the foothills in Colorado. Snow to liquid water ratios of around 3 inches of snow per 1 inch of rain, or liquid I should say. So heavy wet snow, and it's 36 inches of snow. Imagine shoveling that. No thank you. And you'll see this like,
danger must be enormous in the wake of such a thing.
Yeah.
You think, oh my
Yeah.
God, it's like putting on a suit of chainmail.
and you can just see this feature is just sitting here, this trough, it's almost cut off. And we'll see that in the upper level chart. We had rain last Friday. Luckily we don't have rain today, but we kind of had the same sort of wet, cold rain yesterday. And you'll notice at the end here, so here's that trough moving over the western United States. Here's our flare-up of rain. And then at the end of this, here's your severe weather. So it's very obvious in the IR how cold these temps get. They get below 200 Kelvin in the whites there. And so those are very high clouds, very high top severe weather cells. We'll see that again, I'll point it out.
You know what's else is cool is the shelf water off of New England and maritime Canada.
Yeah.
That's the place where you start to get the stratocumulus in the secondary kind of cold air advection. The initial cold advection, you know, mid-March, the water's as cold as it's going to be all year. And you can see that manifest. You don't see those cloud streaks right off the coast as much. They come off the shelf water. Look at that.
Yep, that's exactly
That's
right.
really cool.
So you're seeing the current, yeah. Here's your flare-up of severe weather. Pretty intense tornadoes, I know, in Ohio at least, from this event. And one thing, I looked at the synoptic setup. Most of your energy for severe weather was well to the south of Ohio. So kind of curious why there was a bullseye of northwest Ohio for that, at least intense thunderstorms versus, you know, the expected region near the southwest. There's kind of a boundary sitting just, you know, south of where all the tornadoes hit. So I'm not quite sure why there was such intense convection, and I'll point out those storms as we loop through here. Let's see.
Yeah, and another thing that I noticed, I didn't know that, but there's a pulsation to these, to the development of the really high clouds.
That's right.
All over the place. There's one pulse, there's another one, and then another one.
Yep.
It's really
That's right.
something, all in the same area.
And one thing to point out too, the cold air in Canada, you can see it creeping up underneath the clouds, completely gone by the end of this loop. So maybe that's a sign of things to come. It's eroding further and further north. So those are where we'll get our cold shots, and that's disappearing as the sun angle gets higher and higher. So unfortunately, we might be done with our big snows and big winter, but in the short term at least, we might get a little snow flurries here. So winter's not completely over, but all of your cold air, your cold storms are going to be where that cold air is.
In fact, we're in the week right now where hemispherically, on average, it doesn't seem to be replicated in year to year, but on average, the increase in temperatures around the hemisphere is most abrupt right now, about several days before the equinox. And then it kind of trails off, which is really weird. It's like the final evaporation of cold air in the lower troposphere. This is at 8:50, I should say.
Okay.
So
That has to be tied to the sun angle, I would assume, in the equinox.
I think that's
Yeah.
probably right, yeah. And maybe something with the storm track in the
Could be,
long-term
yeah.
average.
And we've had our warmest winter on record, so that doesn't exactly help if you want winter. If you're Punxsutawney Phil, you're saying I had a pretty good forecast for the entire northern part of the United States. He forecasted, early spring. So maybe he has a career in meteorology.
If he had an opposable thumb, he could flip a coin and do better.
That's very true. No, he was looking at the long-term models. He was looking at the 500 millibar heights. So I'll point out the storms again. Let's see. There's our rain, persistent as it was. Here's your tornadoes, just right in northeast Ohio. And then I think it was mostly just severe weather, severe hail and wind, and not too many tornadoes. It's kind of a bullseye up in Ohio, at least. So could we go to the 500 millibar chart current, please? So we'll pull up the super peats here. Get a look at the troughs and ridges. So here's your nearly, it looks cut off. It very nearly is a cutoff feature. Around this blocking highs, there's two cutoff lows. We have very high amplitude, high and omega block. Looks to be setting up, which you set up a trough over the western United States, and you have continued moisture advection at low levels and upper level divergence across southeast. So that's your general setup for severe weather and precipitation, which is happening right now over the southeast. That's why they've been in the bullseye for a couple days now. As this feature has not moved because it's tied to this block, which has not moved as well. You can also pick out, we're sort of in this, maybe there's a short wave to our northwest. The main feature that we'll look at here is this short wave along with pretty strong temperature gradient. So here's your cold shot coming in for the weekend. Would be nice if this could wait until Monday or Tuesday, but it's not going to. It's going to be cold over the weekend, it looks like. But you can pick it out in this sharp temperature gradient, and it's a very sharp trough. Not too much curvature, but there is a decent amount of shear involved with the packing of these geopotential height lines in the northwesterly flow, and that's on a path exactly towards us. So once this gets here, that's your cold shot of air. In the meantime, we're sort of in this very nice westerly winds at 500, so we'll be in the mid-50s today, sunny. That's what we want for spring weather in this part of the country. And then once this trough dislodge, we'll see more active weather as it continues to move into the eastern United States. So that's a look at the current 500 millibar. Could we get 850 now, please? You see sort of the same things reflected. So here's a feature of interest, our low pressure system. This is low and geopotential heights, and you can see what is assumably a warm and a cold front tied to it in the temperature lines. Here's your cold shot of air. It's almost air completely flowing from the Arctic straight south, maybe a little southeastward with the map projection. But this is unfiltered air coming straight from the northern part of the world. So this is your cold shot of air. We'll get this little warm up out ahead of this low pressure system that we'll see in the surface. And then you can see the reflection of that. Here's that trough that's been sitting over the western United States. And out ahead of it, you sort of have not too much of a synoptic setup. You can see there's cold air advection from, it looks like Green Bay, all the way down towards the Gulf Coast. So here's your cold front that moved through yesterday and is firing up all of that severe weather. And out ahead of it, you have moist flow off the Gulf, and it's fairly warm. So that's where your storms and severe weather are going to be focused along that boundary where you have a moisture and temperature gradient. Can we see the surface map now, please? So we'll see that boundary reflected here. First, there's that low pressure in Canada that's bringing cold air in the teens and single digits out ahead, behind it, and then out ahead of it in the 30s and 40s. We're sitting, it's pretty nice, 45 degrees over 31 with very light winds, and it's sunny. So that feels nice, no matter what the temperature is, I would say. Places to our south are in the 50s, and you can see very nice boundary where the winds shift from south to north. So it's kind of somewhere in the middle part of the southeast mid-Atlantic region, and some rain along that boundary as well. If we scroll down a little more south, thank you, you can see there's a pretty good dew point boundary along it, especially parts of Texas and Oklahoma, where it goes from the 40s in the dew points to the 70s, and very clear wind shift and temperature shift along that. And we're sitting behind a cold front, 45 degrees. That's about as nice as you could ask for, I would say. Most likely, we could be, in the single digits if we had a nice snowpack, if it was a colder setup than it is, but 45 degrees behind a cold front is nice for this time of year. You can still get outside to enjoy it. And then I want to point out there's still lingering snow along the Front Range in Colorado where they had 36 inches of snow. So it's still snowing when you're trying to get out and shovel, concrete snow. And then in the weekend it's going to be in the 60s. So that's classic for, I'd say, the western part of the country, especially now. But this is actually Colorado's snowiest season is spring. And I think March is the snowiest month for them. So right on cue. When you get 36 inches in one day, that'll make your snowfall the most for that part of the year. That's all I want to point out. Is there anything anyone wants to see from what I showed? Perfect. Pass it on then.
Thanks, Patrick.
All right, so this is going to be a little bit different than your normal weather watch. What I want to do is I want to talk about the polar vortex. It's something that you probably heard about, and here we are at the end of the winter. Actually, Pete, can you in Google search ERA 40 Atlas zonal? And I think it's the first thing. Yeah, this one. I'll go to this one. Okay, so I wanted to start with some extremely high level, I guess low level, I don't know, background. And what I want to do is I want to look at the December, January, February, and this is the zonal mean temperature. So essentially what we're doing is at every latitude from the South Pole to the North Pole, at heights from 1,000 hectopascals to 1 hectopascal. So this, here's tropopause roughly here, the cold tropopause in the tropics. Here's your warm tropical temperatures in the troposphere. But what's really interesting, and the reason I wanted to bring this up, is because if you look at the stratosphere, instead of having warm tropics, here's at 1,000 hectopascals, it's warm in the tropics, cold in the polar regions. In the stratosphere, we have a completely weird, setup for temperatures. So this is northern hemisphere winter. So here we have colder temperatures in the northern hemisphere winter. But if you look at this, the temperature as you go from the North Pole to the tropics slowly gets warmer, but it keeps getting warmer all the way to the South Pole. This is weird. This is not what we see in the troposphere, where it's cold in the poles, warm in the tropics, then cold in the poles again. So if you think about this from a basic dynamics perspective, what this is telling you is that the winds in the stratosphere also have to match this temperature distribution because of thermal wind. So what it means is that we have westerly winds in the northern, or in the winter hemisphere, and easterly winds in the summer hemisphere. And so that's what we're going to talk about, is we're going to talk about the polar vortex. It happens in the winter hemisphere. The summer hemisphere does not have a polar vortex. And Pete, if you can go back. So this is December, January, February. And then if you go here, we can look at the zonal mean stratosphere. Where is it? Somewhere over here. Zonal mean wind stratosphere perspective. And then we can go to DJF again. So here we are, northern hemisphere. This is our zonal mean stratosphere jet. This is our polar vortex jet in the winter hemisphere. These are easterlies, no polar vortex in the stratosphere in the summer hemisphere. This is the southern hemisphere troposphere jet. So that's what I wanted to talk about quickly, is just the idea that we have these really strong winds in the stratosphere in winter time. So that's the background. Now if we can go to that climate.gov link.
Got them in the order that you had them.
Okay. Let's see. I think it's going to be. Should be a NOAA. This. I don't remember. Yeah, this one. And then can we zoom in on this figure? So, understanding the polar vortex. So here we are. This is a wintertime phenomena. When we have really cold temperatures contained over the Arctic region compared to the warmer temperatures in the mid-latitudes, the stratospheric polar vortex is really strong. And so what that means is we have really strong westerly circumpolar flow in the stratosphere, and it projects onto the tropospheric jet stream. So that's the idea here. This like swirly tornado-y looking thing is supposed to be the stratospheric polar vortex. It's a circumpolar circulation. It usually has its maximum wind at about 60 degrees north. But when we disrupt this westerly wind, we can start to get a disruption instead of nice circular circumpolar flow. We can have waves develop on the vortex, and then we get this disruption to this circumpolar flow, and it projects onto the tropospheric jet stream, and we can have really meridional flow, a lot of troughs and ridges. And it turns out that in the stratosphere, a lot of this is happening in the largest scale waves, not the synoptic scale waves. So you're going to see things like a huge trough over all of North America, not just a little synoptic scale wave, but a huge trough. So it sets the background flow conditions. So if you have a really big trough, you can start to have short waves develop on that big trough and, change the storm track for a series of cyclones that develop on this background flow. So that's the idea of trying to understand the stratospheric vortex, is that the stratosphere, because it's the stratosphere, it's very stable, it evolves very slowly. So if you perturb it, this is going to last a while. It's going to last on the order of a couple weeks. So if you get in this, wobbly vortex state, it lasts a couple weeks, and then your synoptic waves will evolve on this highly amplitude background state. So you can get really high amplitude weather that is associated with that.
Andrea,
Yeah.
is it right to think that the stratospheric polar vortex imposes itself on the underlying polar jet, or is it the other way around, or is it interaction?
There's an interaction.
Okay.
So yeah, that's a good question. How do we know which one is doing what? If you can bring up that figure that is in the email. Yeah, this one. So this is sort of how we get from stable vortex to wobbly, wavy vortex. And it's a very idealized schematic, so you'll have to think about it. But the source of the waviness for the vortex is the troposphere. So here we're thinking about as you move in this direction, it's time. And this is the troposphere, this is the stratosphere. So the idea is the source of the anomalous waves in the stratospheric vortex is waves from the troposphere. Usually these are the largest scale waves. So huge waves, not synoptic scale waves, but larger scale waves. They can propagate, these are Rossby waves, and Rossby waves are waves, so you can think about a Rossby wave, phase speed and group velocity, and if you have a component of the group velocity that's upward, then you can have waves amplify, Rossby waves amplify in the stratosphere. Eventually, the density decreases with height, pressure decreases with height, you can have wave breaking, and that's how we can have these long-lasting implications for disrupting the stratospheric vortex. When that happens, we can have this downward signal of this disrupted vortex on the troposphere. And the reason that we have this downward is still sort of there's a lot of different ways that this can happen, but essentially because the stratosphere is so slowly evolving, it's like, imposing itself on the tropospheric flow. And you can think of it as just this nudge, this push in the direction to the stratospheric wavy conditions from the top down. So that's really what's going on this side. And so this is going forward in time, but if you look at this, we start with a wavy troposphere, and then we have impacts in the troposphere. So usually there's some sort of pre-tropospheric state for this. If we can go to, let's see, where is it? Yeah, that one. And then scroll down to the first figure. So the idea of thinking about the stratospheric polar vortex is part of this idea that we can do these sub-seasonal to seasonal predictions. And because the stratosphere evolves slowly, it tells us maybe some forcing that might happen on the tropospheric jet at week 2, week 3, week 4 in the forecast. So this is a summary plot of lots of different things that contribute to thinking about forecasts at this time scale, including ENSO, the MJO convection, thinking about land surface memory and all of that, that all contributes. So I'm not saying that the stratosphere is the only thing to be talking about. And right now, actually, the MJO is very active, so this contributes to the forecast. We know we're coming out of an El Nino year, and we have an active stratosphere. So there's a lot of things happening. And Pete, if you go to the CPC page, I think it's this one. Nope, not that one, the other one. I think it's this one. Yeah. So the CPC, the Climate Prediction Center, makes these week 3-4 outlooks for thinking about what the weather might be at these time frames. And of course, when we're out at this time frame, we're not making deterministic forecasts. We're not saying it's going to snow 8 inches or the temperature will be 35 degrees. We're looking at how we shift the climatological conditions to either be slightly warmer, what is the probability of this? So these are the outlooks. We see, here in Wisconsin, chances are going to be above normal temperatures, and maybe northern Wisconsin below normal precipitation. This is going for week 3 to 4. This forecast was made last Friday, so they come out with these new forecasts every Friday. So the new one will be updated this afternoon. But if we scroll down, this is the discussion for how they made this forecast. They talk about the things that go into making these extended range forecasts. And there's a lot of discussion. The El Nino conditions continue. Dynamic models are saying that MJO, this is convection in the tropical Pacific, which is pretty persistent, so it produces a lot of diabatic outflow that can make the jet wavy in certain locations. But then if you continue reading, it also, a sudden stratospheric warming is currently ongoing while the Arctic oscillation is negative. It's a one-sentence kind of throwaway point in here, but this sentence is telling you, okay, the stratosphere is active now, and this precondition, the Arctic oscillation, it basically tells us, is the flow zonal or already wavy? And the negative AO tells us that the hemispheric flow tends to be a little bit more wavy than normal. So it's a hint that the troposphere is ready to feel the stratosphere because it's disrupted. So with that, let's go to, I'm trying to remember the order here. Yeah, let's go to the national one. There we go. And then this is the 60, so the way we measure the vortex is how strong are the winds at 60 degrees north going around the hemisphere. So we look at the zonal mean around 60 degrees north for the winds, and I think, is this already this year, 23, 24?
Yeah.
Okay, so if we click on the 10 hectopascal plot, this is from summer, so June 1st, July 1st to June 30th of 23 into 24. And the black and gray is sort of the background conditions for the last 40 years, where the skinny black lines are the maximum and minimum of the zonal mean winds at 60 degrees north at 10 hectopascals. So 10 hectopascals is about 30 kilometers above Earth's surface. So it's really high up there in the stratosphere. And what you see is that summertime, like I said, we have easterly winds. There's no polar vortex in the summer. We get a polar vortex starting in the fall, and then its max is in January in the northern hemisphere. And then we start decreasing our zonal mean winds, especially this time of year. And then we go back to summer conditions, typically around April. So here we are. This red line is this year. The blue line is last year. The red line is where we are. We had a strong vortex early in the season. And then we had a quick little switch to easterlies. So if you imagine, to get easterlies in the stratosphere, you need to completely reverse the temperature gradient, which is pretty remarkable. And then we go back to normal conditions for a little bit. The transition from red to purple is just using reanalysis data to analysis from a forecast. So we're in the analysis period. We had another warming event. So we currently are in summer easterly conditions in the stratosphere. This happened in early March. We've been in these easterly conditions for a long time. So right now the stratosphere is saying, hey, you want to be wavy, troposphere. So that's what's going on right now. The forecast is to actually recover back to about some weak westerlies. So this will probably be the second sudden warming of this year, which is not unheard of, but it's extremely uncommon. Okay, so let's think about what this means. But before, yeah, good.
Is it fair to view the event in like early, mid-February as the same, or are they going to be two separate events?
So this one,
Is it going to be like,
Yeah.
is it better to think of that as two separate warmings, or one with a little bit of an interruption?
yeah, so normally when people think about this, they say that to be two separate warmings, you need to have at least 20 days between the two. And that's mostly because the things driving this are some large-scale waves that are on the order of, a week or so. So, yeah, this will probably be one big warming event. Okay.
Is there an average volatility for that time series? You know,
So-
if you measured how the variations measure against the standard deviation or something, however you measure volatility, I investigated it once and I forget. But is this more volatile than most years?
In the troposphere?
Stratosphere.
In the stratosphere? That's a good question. Off the top of my head, I don't know. But if I had to guess, I would say yes.
Yeah, okay.
I think a lot of that is sort of the background flow. So because usually El Nino years, I think, tend to have more wave activity in the stratosphere. And actually, we can look at that. So if we go back, and then we go to heat flux. So heat flux, meridional eddy heat flux, is a proxy for the upward component of Rossby wave activity into the stratosphere. So it's a lot, but basically, if this quantity is large, the troposphere is pushing the stratosphere to be wavier. So if we look at this, let's go to the 100 hectopascal at 45. So this is the smooth version. And yeah, so the wave forcing on the stratosphere this year, the red and purple, is kind of staying on the top side of the 50% line. So I would say it's slightly more volatile than normal.
Okay.
So, yeah, but nothing extreme.
It's almost like they're inversely correlated in a way. Tendencies anyway. That's what it looks like for this year. Okay,
Yeah,
thanks.
yeah. Okay. So we have this very disrupted stratospheric vortex. So what I want to do next is go to why we care about this. So we have this wavy stratosphere. There's a lot of things going on. Let's go to, this one. So the stratosphere can have implications for the troposphere in terms of time scales on the order of a couple weeks. So if we scroll down a little bit, I just want to highlight, keep going. So this figure is a composite of different weak vortex events, those sudden stratospheric warming events, and it's a composite of these most recent, and it's the 30 days following 24 different weak vortex sudden stratospheric warming events. And the whole takeaway is that, let's focus on this figure over here, is that the mean surface temperature in the 30 days after one of these events, so a full month, is much colder for most of northern Europe and parts of Asia, and a lot warmer for most of Canada, which is a really interesting signal. And if you think about that, there's a lot, if you want warmer temperatures in Canada, you need to have a lot more southerly flow in Canada, a lot more, essentially the whole circulation is changing, whereas you're going to have a lot more Arctic flow into the continent of Asia and parts of Europe. So there's very large changes in the northern hemispheric circulation in the troposphere after one of these events. And if we scroll down a little bit more in this paper, so this is for particular events. We also see something similar in the southern hemisphere, but if we go down to this one. So these are, and I just want to highlight this, we don't need to spend too much time, but these are different surface impacts associated with stratospheric variability. But people have linked stratospheric variability to cold air outbreaks over North America, to atmospheric river activity, sort of on the west coast, to extreme ice loss events in the Arctic, also to changes in storm clusters. So this is storm track related, extreme rainfall, especially sort of in the transition to springtime. And then in the summertime, we've actually seen final warming events, so around now, have implications for heat waves over Central Asia. So I just wanted to note that. Okay, so now let's talk about what's going on currently. But before I do that, are there any other questions? Okay, so let's go to this strat observe, and let's do this time series. And yeah, that one. So this is a forecast. So this is a dashed line. This is now. It's the 15th. Everything on this side of the line is what has happened already in the, and I think this is the GFS forecast. Is that? I need to step back. I'm too close. Yeah. So what you're looking at here is, so we have easterly winds in the stratosphere, and the forecast from, oh sorry, this is all the GFS, the NASA GEOS-5, the GFS ensembles, Canadian model, and I think this is,
It's the Navy model.
yeah, the Navy model. So all of the models are saying that the stratosphere will recover a little bit as we go forward. But what the interesting thing is the implications of this on the troposphere itself. So if we go to, let's do, yeah, cross-section, and you know what, we'll look at those. Let's go to miscellaneous, and let's look at the, yeah, this one. There should be a drop-down, 3D vortex. So this is what the stratospheric vortex looks like right now. And what we can do is we can say, okay, well, let's find the location of the vortex, and in this case, it's defined as a potential vorticity threshold at different levels in the atmosphere. And in the stratosphere, if you notice this, the vortex doesn't really exist. And if we can step back here, I think here we can go to an earlier forecast period. So let's go, yeah, the earliest one there is. So when the vortex might have existed. So this is what it looked like before the sudden stratospheric warming event. We have cold pull, high potential vorticity directly over the pull at pretty much every layer from a potential temperature. So this is well into the stratosphere. This is above 10 hectopascals at 12 kilometers, or at 1200 Kelvin, all the way to the surface. So we have this nice circular vortex, and if you step forward in time, the waves in the troposphere impacted the structure of the vortex. We started to have it break, and if we keep going, you can start to see the wave breaking actually gets rid of the vortex at upper levels. I haven't looked at this particular forecast itself yet. So that's what's happening. So now we see in this particular forecast, and this isn't quite what happened in reality, but we have these two separate pieces of a vortex. Around each one of these, we have counterclockwise flow all the way through these columns. The center of these is going to be cold, and everywhere else is going to be warm. So now you can see that basically there's warm air over the high latitude regions. The cold air wants to follow these over North America and over Asia. So now if we go to, what is this, valid? So this is valid coming up here at the end of the week. If we go to, let's go to Alicia's maps here. So this is now looking at the potential temperature on the tropopause. So this is the 2 PDU surface. If we step forward in time, and we look at this, and really what I want you to do is more look at the shape of the flow. You can start to see it getting pulled into two separate directions, especially towards the end of the forecast period here. So this is going to be our colder vortex region as we go forward in time. I think this is the last time period. But you can get a hint that the vortex is also separating right at the tropopause region associated with this wave breaking event that's happening well above the surface in the stratosphere. So as we look forward, the CPC last week was saying, maybe there'll be some, influence from the stratosphere, but we don't know what it's going to be yet. But as we start to see the whole cold tropopause region starting to split in two, we can really see that there's going to be probably some impacts over Asia. And the coldest part of the component of the tropopause will probably be a little bit too far east, at least in this forecast, to really have implications for us in Wisconsin. But we can probably assume that there's going to be a really active North Atlantic storm track as we head into the end of March. So I think in terms of implications, I think we can end it there. But I do want to point out that the coldest air, actually, if we go down, I think one of these is 850 temperatures maybe. Yeah. Oh. This isn't what I wanted. Yeah. Sure. But as we look at this, some of the coldest temperatures, and you can see the difference between the thickness contours, the 540 and above thickness contours are red, and below 540 is blue. So we're definitely on the colder side of those thicknesses at the end of this forecast. And we can start to see there's going to be an active East Coast storm track in association with this elongation of the tropopause low region. And so I think, without getting into too much more, we can end it there. But I do want to mention that typically when we think about final warmings in the stratosphere as we transition from our wintertime circulation to our summertime circulation, the timing of the final warming can have implications for the springtime weather for an extended period of time. So this is something to think about, and these weak vortex conditions might have implications for a wavier springtime. But this is still something that, it isn't a solid, things are to still investigate, but to keep an eye out for sure. So,
I was thinking about the same thing a little bit, maybe from a different perspective. When you get close to the final warming, climatological period for the final warming, there are some obstacles that can't be overcome by the stratospheric vortex. You would imagine by mid-April, there's no way you can overcome those. But if you get really close in mid-March and you've had a warm winter, and you split this thing into these two vortices now, is that really just the first inkling of this thing falling apart?
Yeah.
How can you tell?
No, I think it is. And I think that it's really hard for the stratosphere to recover after an event like this. Depending on the timing, so when you are in terms of like how much radiation is actually hitting the North Pole, you can have completely different impacts. And I think that that's a really good question.
Okay.
What's interesting is that given this event happening sort of at the beginning of March, there's still enough cooling happening in the stratosphere where you can recover the upper stratosphere. So actually, I know I said I wasn't going to look at any more plots, but I think it's going to be I think this one or that one. I don't remember which one. Yeah, this one. So let's look at, actually, let's go to a different year because I know what a different year looks like. We're going to use as an example 2013. We're going to look at these zonal mean height anomalies in the northern hemisphere. Yeah. Okay, so this is a weird plot to look at. Sometimes these are called dripping paint plots. But the whole idea that I want to focus on is that the color fills are telling you how anomalous the height over the polar region is. So if you have higher heights over the polar region than normal, then you're going to have weaker circumpolar flow. If you have lower heights, you're going to have stronger circumpolar flow. And it's telling you how it looks from the stratosphere all the way to the troposphere. So everywhere you see red, it's higher heights, wavier conditions at that location, or around the circumpolar regions. Blue is stronger westerlies. But what's interesting is you can see that there was a sun stratospheric warming event in January 2013. You can see that in the stratosphere, and then it kind of drips down into the troposphere for the next 3 months. So this was a midwinter sun stratospheric warming. And you'll also notice that after this, the stratosphere recovers because it gets really cold and drips down into the troposphere, and actually impacted springtime. What was also interesting is that there was a really strong final warming event that had implications into the summer, which was also interesting. So there's a lot of really weird things going on, and we're trying to figure them out and how we can use this to make better sort of week 2, 3, and 4 predictions. So I'll end it there for real.
That's neat.
Yeah. So thank you.
Thank you. That was really interesting. I guess maybe I'll just say 2 things or so about the weekend. Do we have time for that?
Sure.
Maybe just
Yeah,
a minute.
I know I didn't have an immediate forecast.
Oh, that's okay. Let's just take a look, Pete, at the 850 milliwatt shot. Yeah, and we'll just go a couple of ways forward. I think the story is going to be it's going to get colder, and I think that's what people might be most interested in. So here's valid tonight. So here's the cyclone that I think Patrick drew our attention to further up to the northwest. It was beginning to develop. Now it's to the southwest of Hudson Bay. And you can see there's a baroclinic zone that's fairly intense right in there. And over sort of southern North Dakota at 850. And then this weaker warm frontal structure from central Dakotas towards us. And that was also highlighted in the ops. Let's go 12 hours ahead. So this will be 24 hours tomorrow morning. And by then, that structure looks a little bit more robust, especially the cold front. The warm front gets washed out. It might have had some sort of lee-side origin a little bit. That there wasn't particularly strong flow over the terrain in the 2 days before, but there might have been a little bit of warmth left over there from prior westerly flow. But anyway, the cold front's quite strong, right all the way from Green Bay to the southern part of South Dakota. So we're right on the edge of it by early tomorrow morning at 850. At the surface, it might be closer to us because these things slope backward with height. So somewhere between 7 a.m. tomorrow and probably noontime, the cold front, however strong it is at the surface, will make its way through. Let's go 12 hours further than this, Pete. So this will be Saturday. This is now Sunday morning. It's a whole day ahead. We're well into the cold air by then, and the cold front's made its way into the Tennessee Valley. So substantially colder into the day Sunday, beginning tomorrow morning, I think. And let's see if this frontal passage brings any precipitation in the forecast. Let's look at that's too far ahead. Let's go to maybe 24 hours when it's just about on us, probably in the thickness field too as well. No, most of the precipitation's up in here. I presume this is the region of PVA by the thermal wind, characteristic of these kind of clipper-looking storms. That's where they get most of their forcing for ascent. That's where the development is. And the air is really dry, so there's just nothing that's going to happen apparently with this the passage of the cold front, despite the fact that it'll be characterized by convergence, as they always are. And I think that's true when we go to 36 and 48 hours as well. Here's 36, yeah, the storm, the cloud head stays really with the sea level pressure minimum, and we have continued geostrophic cold advection over us. There'll be a limit to it eventually, but we're not at the limit yet. And that's Saturday night, so remains dry at least. I don't know if it remains cloud-free. And then by Sunday morning, we're further into the cold air. We're almost at the limit, which is the 510 thickness line, I think, for this particular event. So we're going to start to see some, going to continue with cold advection. Maybe it will lessen during the day on Sunday, as it looks like the strongest thickness gradient already to our south. Although the winds will pick up, it'll stay windy, but with less advection. So I think it's going to be kind of a typical St. Patrick's Day weekend actually around here. You know, not really warm, windy, getting colder. I think it'll stay dry. So that's, I guess, good. We had a pretty good soak this week. But it'll stay dry, but wind chills will be uncomfortable. It won't be fun to be down at the square watching, you know, the old Irish run around the square and throw candy to kids. And it's going to be kind of miserable. So that's how it's going to be, it looks like. Maybe we should quit because we're at 1 o'clock. So thank you, Pete. Andrea, thank you so much. Patrick, thank you too. That was a great discussion today. So, Andrea.